Let's see the question. The number of 7-digit numbers divisible by 9 formed with the digits 1, 2, 3, 4, 5, 6, 7, 8 and 9 when repetition is not allowed. Yes, what kind of a number is required? The number must be a 7-digit number and it should be divisible by 9. Now these two are the important conditions. Now when do we say a given number is divisible by 9? Yes, for a number to be divisible by 9. What is the rule of divisibility? It is divisible by 9 if the sum of its digits is a multiple of 9. So if a number satisfies this condition that sum of all the 7 digits that are present in it is divisible by 9, then such a 7-digit number would be divisible by 9, right? Now we need to look at the given problem with the choices 1, 2, 3, 4, 5, 6, 7, 8, 9 with which satisfy this kind of a condition that the 7 digits which we select, the sum must be divisible by 9. Now let's first, before proceeding, find out what is the sum of these 9 numbers. What is sum of these given 9 numbers? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, which is sum of first 9 natural numbers, is 9 into 9 plus 1 by 2, that is 45. Now if you observe, all the 9 digits when considered, the number is, sum is coming to be 45 and this number is divisible by 9. Now as the sum of these 9 digits is divisible by 9, but we need to form only a 7-digit number, right? So what we need to do? We need to reject 2 of these 9 numbers. And how should be the rejection? The rejection should be in such a way that the rest of the 7 digits which are remaining should be divisible by 9, right? Then one important observation is, for the 7-digit number to be divisible by 9, the 2 numbers which we wanted to reject must also give a sum of 9, because already 45 is divisible by 9. Then the rejected pair, what are the possible rejections? The possible rejected 2 digits must be in such a way that their sum itself must be divisible by 9. Then only the rest of the numbers will be still divisible by 9. That means they could be either 1 and 8. So what happens when we reject 1 and 8? The rest of the total would be 36, because already 9 is been removed from this total. We removed 1 and we removed 8. Then the remaining digit sum would be 45 minus the rejected numbers 9. That is 36 would be the remaining total. Then obviously 36 is divisible by 9, right? Now similarly, we can also reject 2 pairs, that is 2 and 7. And we can also reject 3 and 6. And we can reject 4 and 5. With each of these rejection, we will have a 7-digit selected, and the 7-digit selected sum will be always divisible by 9, because from a total 45 we are subtracting 9 sum, then the rest of the sum would be always 36, which is divisible by 9. Then what happens? This rejection can happen in 4 ways. Rejection of each of this pair would also give us selection of the remaining 7 numbers. So shall we say the remaining 7 digits, in each case the sum is divisible by 9, because we have rejected only 9 from the total. So for all the remaining 7 digits, the sum would always be 36, which is always divisible by 9. So what do we require now? We need to form different numbers with this 7 digits which we have selected. Therefore these 7 digits which we have selected by rejecting the 2, right? These 7 digits can be arranged in how many ways? 7 digits in 7 positions. That can be arranged in 7 factorial ways. Now these 7 factorial ways corresponding to each of the rejection of 2, that is selection of 7 digits. Therefore, what is the total required numbers? Therefore, the total required numbers would be 4 different cases of selecting 7 numbers, and in each case coming up with 7 factorial arrangements. So there will be 4 times 7 factorial arrangements, which is present at option D satisfies the question, right? It's a case of divisibility rule which is applied in the permutations and arrangement, where we need a divisibility by 9, right?